This is SpaceTime Series 28, Episode 16, for broadcast on the 5th of February 2025. Coming up on SpaceTime, the Moon not as geologically dead as previously thought, a new mission to unlock the secrets of the planet Venus, and how the Saturnian moon Titan maintains its atmosphere. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has discovered that the Earth's moon may not be as geologically dead as previously thought. The findings, reported in the Planetary Science Journal, are based on observations of small ridges on the lunar far side. Scientists have studied the moon's surface for decades in order to help piece together its complex geological and evolutionary history. Now, evidence from lunar maria, they're the dark flat areas of the moon filled with solidified lava, suggests that the moon must have experienced significant compression in its distant past. Researchers suspect that large arcing ridges on the moon's near side were formed by contractions that occurred billions of years ago as the moon cooled down and shrank, and they concluded that the moon's maria has remained dormant ever since. However, a new study reveals that what lies beneath the lunar surface may be more dynamic than previously thought. The authors discovered that small ridges located on the moon's far side are notably younger than those previously studied ridges on the near side. One of the study's authors, Jacqueline Clark from the University of Maryland, says many scientists believe that most of the moon's geological movements probably happened 2.5 to maybe 3 billion years ago. But Clark and colleagues are seeing that these tectonic landforms have been recently active around the last billion years or so, and may still be active today. The authors say these small mare ridges seem to have formed within the last 200 million years or so, which is relatively recent considering the moon's timescale. Using advanced mapping and modelling techniques, the authors found 268 previously unknown small ridges on the lunar far side. The ridges typically appeared in groups of 10 to 40 in volcanic regions that likely formed between 3.2 to 3.6 billion years ago, in narrow areas where there may be underlying weaknesses in the moon's crust. Now, to estimate the age of these small ridges, the authors used a technique called crater counting, and they found the ridges were notably younger than other features in their surroundings. Crater counting is pretty simple. Essentially, the more craters a surface has, the older that surface is likely to be. That's because the surface has had more time to accumulate more craters. After counting the craters around these small ridges and seeing that some of the ridges actually cut through existing impact craters, the authors believe that these landforms were tectonically active in the last 160 million years. Interestingly, Clark noted that the far side ridges were similar in structure to the ones on the near side, and that suggests that both were created by the same forces, likely a combination of the moon's gradual shrinking and shifts in lunar orbit. The Apollo missions of the late 60s and early 70s detected a series of small shallow moonquakes, and the new findings suggest that these small ridges might be related to similar seismic activity. Learning more about the evolution of the lunar surface could have important implications for the logistics of future moon missions. Clark hopes that future missions to the moon will include tools like ground-penetrating radar so researchers can better understand the structures beneath the lunar surface. And knowing where the moon is still geologically dynamic has very real implications for where NASA plans to put its astronauts' equipment and infrastructure when it finally returns to stay on the lunar surface. This is SpaceTime. Still to come, a new mission to unlock the secrets of the planet Venus, and how the Saturnian moon Titan maintains its thick atmosphere. All that and more still to come on SpaceTime. There's been a lot of talk in the scientific media, including here on SpaceTime, about NASA's new mission to study the planet Venus. It's called DaVinci. That stands for Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging mission, which is slated to launch in the early 2030s. DaVinci will explore Venus with both an orbital spacecraft and a descent module. NASA says DaVinci embodies the spirit of innovation and exploration that its namesake Leonardo da Vinci was famous for. It'll be the first probe of the 21st century to brave Venus's atmosphere as it descends from above the planet's cloud tops down to its heat-soaked surface. Two other missions, NASA's Veritas and the European Space Agency's Envision mission, will also explore Venus in the 2030s, but they'll both be doing that from orbit. The DaVinci spacecraft will study Venus's clouds and highlands during 2 flybys. It'll also release a spherical meter-wide probe that'll plunge through the planet's thick atmosphere and corrosive clouds, taking measurements and capturing high-resolution images of the Venusian surface as it slowly descends. The DaVinci mission will be the first to closely explore Alpha Regio, a region known as a Tesserae. So far only found on Venus, where they make up about 8% of the planet's surface, Tesserae are highland regions, similar in appearance to rugged mountain tabletops on Earth. Geologists believe they may be exposed cratons, ancient structures that have extended up through the mantle and crust. Previous missions discovered these Tesserae features using radar instruments, but of the many spacecraft that dove through Venus's atmosphere between 1966 and 1985, none studied or photographed these Tesserae. Thought to be ancient continents, Tesserae, like Alpha Regio, may be among the oldest surfaces on the planet, offering scientists access to rocks that are billions of years old. By studying these rocks, DaVinci scientists may learn whether Venus ever had continents and oceans, and how water may have influenced the surface. As well as being Earth's nearest planetary neighbour, Venus is considered to be Earth's sister planet. They're both almost the same size, with a similar mass and diameter. Both were formed under similar conditions, out of the same materials, and in the same part of the solar system. In fact, Venus once excited speculation that it could host the first human colony in space. See, back in the 50s and 60s, scientists thought the dense cloud cover meant lots of rain. After all, it's closer to the sun than the Earth is, so temperatures would be hotter and more humid. That would mean more water evaporation and more rain clouds. So, scientists of the day envisaged that under its thick cloud cover, Earth's sister planet was covered in a lush green tropical rainforest. Think Amazon jungle on steroids. And more rain probably meant a higher oxygen content too. And so some scientists even began speculating that the tropical rainforests of Venus somehow meant lots of dinosaurs. Of course, we now know that if Venus is Earth's sister planet, then it's a twisted sister with a massive runaway greenhouse effect. In fact, Soviet and American probes have revealed Venus to be the nearest thing to hell in our solar system. Its surface is scorchingly hot, with average temperatures of 462 degrees Celsius. That's hot enough to melt lead. And those thick, opaque, planet-shrouding clouds, well, they do cause rain. But the rain isn't water. Instead, it's droplets of metal-eating sulfuric acid. Now, scientists have seen what looks like snow caps on some of Venus's taller mountain ranges. But the snow isn't frozen water. It's actually metallic. Venus's clouds are so heavy, they crush the planet's rich carbon dioxide-based atmosphere, acting like a sort of lid on a pressure cooker and giving the planet a surface pressure 92 times greater than the average sea level surface pressure on Earth. The surface is dominated by over 1,600 volcanic structures, more than any other planet in the solar system. Its surface is 90% basalt and consists of a mosaic of volcanic lava plains, showing evidence of regular periodic resurfacing by floods of magma. Now, this indicates that volcanism played and maybe still is playing a major role in shaping the planet's surface. Even Venus's orbital characteristics are strange. It circles the Sun every 224.7 Earth days, but it rotates in retrograde compared to most other planets in the solar system. In other words, the Sun rises in the west and sets in the east, and the rotation rate is incredibly slow. A day on Venus lasts 243 Earth days. In other words, a Venusian day actually lasts longer than its year. This report from NASA TV.
Venus, a planet with an ocean of air unexplored in the ways we look at the worlds around us and beyond. We're going back to that ocean of air at our sister world with a mission inspired by Leonardo called DaVinci to explore from the cloud deck to the surface over a region of mountains that could hold clues to how the early history of worlds like Venus and Earth worked. But by reading the chemical fossils in the atmosphere, the dynamics, and the other forensic clues to how an entire world with this ocean of air works, we'll learn about not only our own solar system and the history of Venus and whether it was habitable at one point, but also push that record forward to explore exoplanets that are like Venus, which we suspect are abundant around favorable stars. DaVinci will be the gateway that opens that door so we can explore better here and apply that forward beyond as we go into eras of gigantic observatories beyond James Webb, like the Habitable Worlds Observatory, Venus is waiting, and we can't wait to get back there.
This is SpaceTime. Still to come, a new mission to study how the Saturnian moon Titan maintains its atmosphere, and later in the science report, new research shows dormant volcanoes can still retain massive magma chambers. All that and more still to come on SpaceTime. A new study suggests that the Saturnian moon Titan maintains its unique nitrogen-rich atmosphere through high-pressure chemical reactions deep below the surface. The findings, reported in the journal Geochemische et Cosmochemische Acta, based on laboratory experiments which have produced gases similar to those found on the Saturnian moon. Titan is the second largest moon in our solar system after Ganymede, and it's the only one that has a significant atmosphere. It's also the only world in our solar system other than Earth where clouds rain down liquids onto the surface on a regular basis, forming streams and rivers which eventually flow into lakes and seas. But instead of Earth's liquid water, on Titan, the weather's so cold, the rain is liquid methane and ethane. Now there is water on Titan, but it's frozen solid, so hard that it forms much of the moon's bedrock. The study's lead author, Kelly Miller from the Southwest Research Institute in San Antonio, Texas, says while just 40% the diameter of the Earth, Titan is an atmosphere 1.5 times as dense as the Earth's, even with its lower gravity. Miller says walking on the surface of Titan would actually feel a lot like scuba diving. The origin, age and evolution of Titan's atmosphere, which is roughly 95% nitrogen and 5% methane, has puzzled scientists ever since it was first discovered in 1944. Miller says the presence of methane is critical to the existence of Titan's atmosphere. See, methane is removed by reactions caused by sunlight, and it would disappear in about 30 million years, after which what's left of the atmosphere would simply freeze onto the surface. Now, because of methane's short geological lifespan, scientists think some sort of internal process must be replenishing the methane. Miller, who was also the lead author of a 2019 paper published in the Astrophysical Journal, has proposed a theoretical model to show how the moon's atmosphere has developed and is being replenished over the years. The paper hypothesizes that large amounts of highly complex organic materials are heated up in Titan's rocky interior, and that releases nitrogen as well as carbon gases like methane. These gases then seep out onto the surface, forming a thick atmosphere around the moon. Now, this theory is corroborated by recent experiments that heated organic materials to temperatures of around 250 to 500 degrees Celsius at pressures of up to 10 kilobars in order to simulate the interior conditions of Titan. And the experiments produced carbon gases like carbon dioxide and methane in sufficient quantities to help supply Titan's atmospheric reservoir. The paper is largely based on NASA's Cassini-Huygens spacecraft, which launched in 1977 and explored the Saturnian system between 2014 and 2017. During that mission, Cassini deployed the Huygens lander, which descended through the atmosphere, landing on Titan's surface. Images show a surface which felt like wet sand. NASA plans to launch another mission to the Saturnian system in 2028 with a spacecraft helicopter drone named Dragonfly. The Dragonfly quadcopter will be designed to explore Titan up close and investigate whether environments at Titan could have ever been conducive for life. This report from NASA TV.
Our next New Frontiers mission, Dragonfly, will explore Saturn's largest moon, Titan. Dragonfly will be the first drone lander with the capability to fly over 100 miles through Titan's thick atmosphere. Titan is unlike any other place in our solar system and the most comparable to early Earth. The instruments on board will help us investigate organic chemistry and search for chemical signatures of past or even present life.
So we have on Titan opportunity to observe the processes that were present on early Earth when life began to form, and possibly even conditions that may be able to harbor life today.
One of the things that is particularly exciting about this mission is that we can do the very detailed chemical measurements, but be able to put them in the context of Titan as a system.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that temperature-related deaths in European cities could increase by up to 50%, resulting in some 2.3 million additional deaths by the end of the century. The findings, reported in the journal Nature Medicine, based on climate simulations using data on 854 urban areas across 30 European countries. These were used to estimate deaths from very cold and very hot temperatures, with increased deaths from extreme heat outpacing increased deaths from extreme cold. The authors claim strong climate change mitigation measures could reduce the number of additional deaths to just over 250,000 people by the year 2100. Scientists have discovered that, contrary to popular belief, dormant volcanoes sleeping for hundreds of thousands of years can still retain massive magma chambers. The findings, reported in the journal Nature Geoscience, found large magma chambers lurking beneath 6 volcanoes thought to be dormant in the Pacific Northwest Cascades Range. The new discovery challenges existing ideas of exactly what separates an active volcano from a dormant one. The authors used seismometers to identify persistent and large magma chambers in all 6 of the dormant volcanoes they studied. The results suggest that eruptions do not always completely drain a magma chamber. Instead, it will release some of the excess volume and pressure, and the magma chamber can then slowly be expanded and refilled over time as the crust gradually melts. Chinese scientists have successfully used embryonic stem cell engineering to create a bipaternal mouse, that is, a mouse with 2 dads, which was able to survive until adulthood. A report in the journal Cell Stem Cell claims the authors had attempted to create bipaternal mice before, but the embryos all stopped growing. In this new study, they focused on imprinting genes which regulate gene activity and were thought to be a fundamental barrier to creating a mouse with 2 parents of the same sex. The authors modified 20 key imprinting genes, finding that not only did this allow the creation of bipaternal animals that sometimes live to adulthood, but it also led to more stable stem cells. However, only around 1 in 8 of the viable embryos developed until birth, and not all the pups that were born lived to adulthood due to developmental defects. Also, those that did live to adulthood had altered growth and shortened lifespans and were sterile. Chinese company DeepSeek has developed a new AI chatbot which it claims rivals ChatGPT. The new technology was reportedly developed using fewer and less advanced chips than its American rivals. It's now quickly become the world's most downloaded app, causing technology stocks to crash globally. However, DeepSeek isn't really that good. It's heavily censored by the Chinese Communist government and refuses to discuss topics which are sensitive to Beijing, including the Uyghur people's enslavement in so-called re-education camps, the slaughter of Falun Gong members for forced organ donations, and the bloody 1989 Tiananmen Square massacre. There are also major security concerns with DeepSeek. All your personal data, contacts, searches, internet history, including text, uploaded files, feedback, chat history, video and audio inputs are collected automatically. Of course, this isn't the first time there's been concerns about Chinese technology. In 2018, the Australian government banned Chinese telecommunications giant Huawei from its national 5G network, citing national security concerns. It's also banned the use of the TikTok app on Department of Defense and government cell phones and computers. See, as a Chinese firm, DeepSeek's required to follow China's strict censorship laws and regulations, ensuring the new AI conforms to Beijing's communist values. Technology editor Alex Zaharov-Reutt from TechAdvice.life has tested DeepSeek, and here's what he found.
Well, DeepSeek is an AI chatbot in the style of ChatGPT or Copilot or Grok, and its breakthrough is that it seems to deliver very similar sorts of results to what you'd get with ChatGPT. In fact, some of the benchmarks show that it's more accurate. But the creators claim to have done this without the massive investment in H100, top-of-the-line NVIDIA chips, nor the billions of dollars, if not tens or even hundreds of billions of dollars of investment that has gone into creating this algorithm. Now, an interesting thing is that when you download the app, you have this option to tap Deep Research, I think it is R1. And what happens then is that you see the AI reasoning with itself, sort of giving itself instructions on how it's going to respond to your question, even harking back to previous interactions that you've had. And then it gives you the response. So we haven't actually been able to see AI do that. Normally AI is a black box. There is this concept of explainable AI, which people want want, so they know what the AI is thinking and why it's coming up with those responses. And again, as I said, this is something we haven't seen with the other models. Now, the claim is that this was done for $6 million US, and the trick is that instead of having huge amounts of processors to generate and calculate each token, this new model is able to somehow predict the tokens it would need. But the criticisms are that it has been using ChatGPT's own results and research to come up with its answers, that it is getting a lot more funding from the Chinese government than is being led on. And it is actually using H800 chips. These are NVIDIA chips designed to be sold into the Chinese market, but they have about half the chip-to-chip speed in terms of being able to talk to each other. So this is meant to slow down the Chinese advancements. There are concerns that the app will take your IP address and your logs and the version of the operating system and the hardware that you have, and it will also, like TikTok, capture your keystroke rhythms and patterns. Now, this is not actually key logging where it's getting your exact keystrokes that you're typing, but for security and sort of other nefarious, sounding purposes, it is capturing this information to verify that it's you. And the concern is, and people have claimed that it's capturing your passwords and able to take your photos and images, but I don't see any evidence of that. I mean, other apps are capturing this keystroke information as well. There was talk that Facebook, even if you weren't hitting send on a post you were making within its app, it was still capturing all that information anyway, which is worse than what is claimed with DeepSeek. But it is true that if you insert or input information into DeepSeek for it to do its calculations and come up with an answer, that is information you are giving to the system, which you can put into a profile against your username that you have to sign up with, and it is stored on Chinese servers. So look, I downloaded it, I tried it, I looked at it, it works, it's pretty cool. I've since deleted it because I have ChatGPT, I have Grok, and I don't know whether to trust this particular app or not, but it is the number one app in the US, in Australia, and other countries as well. So a lot of people have looked at it. And if it is true that the system can do a better job with resources than what the current models in the US are able to come up with, well, it's open source. So that information can be easily subsumed into ChatGPT or Grok or other systems, and they can get an incredible boost as well. And look, the final story on whether this is some giant spy tool is yet to be told, but it's horses for courses. You can play with it and find out for yourself, but you'll get the same sort of results you'll get from ChatGPT or Grok, both of which you can access for free.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.